So as we talk about the physical properties of ideal gases, have your list of assumptions from the kinetic molecular theory available so that we can explain these different physical properties of gases. So the first one is expansion. Gases completely fill any container that they are in. So if we have a container that is smaller, right, and has 5 gas particles, they're all the same. And then we have a larger container, we put those same 5 gas particles inside of this, you fill up the entire space, okay? So which of the assumptions explains this physical property? So I'll give you a moment to think about it before I write it down. There's 2 assumptions that explain expansion of gases. Okay, so hopefully you had time to think about it. And the first one is assumption 3. So what does assumption 3 say? It should be next to you. Right? It says gases move rapidly in all directions. So I'm not going to write it down since you have the assumptions already, but they move rapidly. Right? Doesn't matter what direction they're in, they're moving rapidly. The other assumption that explains this is assumption 4. So what does assumption 4 say? It says, right, gases move without significant attraction or repulsion between them. So the forces of attraction and repulsion don't drive them. So they aren't attracted to each other, but they're also not repelling each other. So they just fill up whatever space they are in. So that's assumption 4. Okay. The next physical property is fluidity. So gases are considered fluids because they glide past each other. So once again, which of the assumptions of the kinetic molecular theory explain this physical property? So take a look at the assumptions and figure out which one explains it. And if you want more time to figure out any of these, you're free to pause the video, but I'm going to continue. So if you think about it, right, if the gas molecules are gliding past each other, let's see if I can try and draw this. But this gas molecule is just going past that gas molecule. There is no, remember, assumption 4, so it's actually assumption 4 here, which we just talked about. So there are no attractive forces. We'll say that's the force of attraction. There's no attractive forces between the 2 gas molecules. So if there's no attractive forces, they're going to glide past each other because they're not going to be attracted to each other, so they won't stick together. That's why gases are considered fluids. Okay, the next physical property is low density. Gases have much lower density than liquids or solids. So we're talking about when we're talking about the same substance. So if we have water, the density of water vapor is much lower than the density of liquid water or ice. And it's about 1,000 times less. So it's much, much smaller. So which assumption would explain this physical property of gases? Once again, feel free to pause, but I'm going to continue. So assumption 1 of KMT, the kinetic molecular theory, says that the particles are much farther apart to each other in a gas than in the liquid or solid state. And we know this from just basic chemistry. We know that gas molecules are very, very far apart. So assumption 1 says this. And what does that have to do with density? Well, if we think about density, what is density? Density is mass over volume. And what we know about division, right? Remember, we said in expansion, so looking up here, volume can increase, right? Volume increases easily. So if this volume is increasing, it's much bigger in gases. What happens when your denominator is much bigger, right? The whole thing gets smaller. So density is small because volume increases in a gas. Okay. The next one is compressibility. So volume decreases when pressure increases. Let's see if I can draw this. So if we have a container and the same container with 5 gas molecules, and we decide, okay, we're actually going to increase the pressure, which just means we're going to push down, right? We're going to increase the pressure on this. So pressure. And the same 5 gas molecules. This was the original volume, and now this is the new volume, right? This volume is bigger. But when pressure is increased, volume is smaller. Which of the assumptions explains this physical property? Assumption 1. Right? We just went over this. So assumption 1 says gas molecules are very far apart from each other. But more importantly, because they're far apart, there's a lot of empty space. So since there's empty space, when you add pressure, the molecules are able to get closer together, which therefore decreases the volume. So those are the 4 physical properties of ideal gases. There are 2 more I want to discuss. So I'm going to erase starting from the top. So if you need to copy any more notes, that's fine. You can also pause the video if you need to, but I want to make room to talk about 2 more physical properties. Let me erase this one too. Okay, and everything I'm talking about is in your book, chapter 10, section 1. So if you want to use that as a reference, that is a good source as well. So the next 2 physical properties, talk about them together, are diffusion and effusion. So diffusion is a spontaneous mixing of particles of 2 different substances. So if you have 2 different types of gases, they're going to mix together spontaneously. And this is caused by the random motion. So we'll say spontaneous mixing. Mixing of 2 substances. Okay, so which assumption would explain this? Assumption 3 would explain diffusion, because assumption 3 talks about the random and continuous motion of gases. So if they're constantly moving around, then if you mix the gases, they're going to mix together because they're constantly moving. Effusion is process of gas particles under pressure passing through a tiny opening. Okay, so particles, if you add pressure to gas particles, they'll pass through a tiny opening. So that's effusion. Now, the important thing here is the rate of diffusion and effusion is dependent on the size of the particles and the speed of the particles. So if you increase the speed, I'm going to shorthand this, then you increase the rate of, I'm just going to put diffusion and effusion. Okay, so if you increase the speed, you increase the rate of it happening. If you decrease the mass, then you increase the rate of diffusion and effusion. Right, so if you're increasing the speed, the particles are moving more rapidly, therefore they're going to mix quicker or pass through an opening quicker. If you decrease the mass, so now if you're smaller, you're able to travel quicker. So that also increases the rate of diffusion and effusion. So the physical properties we talked about were expansion, fluidity, low density, compressibility, diffusion, and effusion. And those are the physical properties of ideal gases.